New research has identified the last universal common ancestor as having been much earlier than we thought, and that may have implications for life on Mars and possibly where life came from here. I will note that I'm not totally happy with this because I was always of the mind that life probably started on Earth several unique times before it took hold, but this is the problem. The Earth is only 4.6 billion-ish years old, and researchers have found that the last common ancestor of everyone is about 4 billion years old. That means Earth had only existed for about 600 million years before life popped up. Even weirder, it didn't pop up alone. Bacteria, the very earliest that we can identify, already had an immune system, meaning they were already fighting other stuff by the time they turned up. This could have a lot of different reasons for it. This might mean that when life was first starting to pop up, other stuff that was akin to life but not life also existed, i.e. bacteriophages. The other idea of how viruses came to be, and that is more applicable to us humans, is that little packages of DNA are sent throughout our bodies, and then some of them just went rogue. This idea does not support that, although it still is possible. Let's talk about what 4 billion years ago means for life on Earth and where it came from. There is a possibility that life already having an immune system might have meant that it popped up somewhere else. That is not a guarantee, it is a consideration. But what about life on Mars? What we're seeing is that life is going to pop up very quickly given the right conditions, and Mars is our neighbor and it had the right conditions. Researchers have been seeing an awful lot of stuff that does look very much like signs of life on Mars. Things that look like fossils would be on Earth. Of course, we won't know for sure until we get a base out to Mars, which is in the works. And while things like amino acids could potentially be pulled out of rocks, Mars does have ice, and that looks like a much better target to figure out if there is life still there, or if there was life. So researchers wanted to test the conditions in which ice exists on Mars to see if amino acids, proteins, could still survive. So they replicated the conditions on Mars, including the very low temperature and exposure to gamma radiation. That's a kind of radiation that knocks electrons off of your DNA. They estimated that on Mars conditions, amino acids could survive for 50 million years. Now do know that Mars may not have an atmosphere, but that doesn't mean that the conditions are not such that extreme bacteria could still survive. Even if there was life 50 million years ago, if that was the absolute cutoff, we're likely to be able to find stuff there. Even deeper in the ice where it's not exposed to as much gamma radiation is also a consideration. The other thing you'll want to know about Mars is that it used to have liquid water. It no longer has an atmosphere, and that's very likely because it no longer has geothermal activity. Yes, you do need stuff like volcanic activity in order to keep water from turning into hydrous minerals. So water just popping an OH on a mineral, so no longer liquid and not great for life. It's unlikely that it is entirely devoid of liquid water, because there is at least ice there. That ice is also going to be a source of water when we humans get there. One of the things I've been dancing around is the amino acid issue. We use 20 amino acids, bacteria use 21, and viruses use a bunch that are not otherwise found in nature. That also goes for DNA. So ATCG, there's no reason you have to only use those. But here on Earth, because everyone uses the same ones, it's very likely we had a common ancestor. There's also the issue of how we code for them. So if we look at life on Mars and it has a similar genetic code to us, that is a very good sign that we must have come from the same ancestor. And then the question will be, where did it form first?